This is a moment's question from the CCEA practice paper from February 2022. Let's take a wee look then at the question. This is question number 3. Uniform beam AB of mass 8m kilograms and length 2 meters is smoothly hinged at end A to a fixed point on the wall as shown figure 2 below. The beam is maintained in the horizontal position by a light inelastic string attached to the point D at the wall and the point C in the beam. The string is inclined to the beam at angle beta. AD is 1.2, AC is 1.6, and CD then is going to be of length 2. By taking moments about A, find the tension in the string in terms of M and G. So we have that, and then we're going to find our force in at the hinge. You can do it a couple of different ways. You can do an R going this direction here. In this particular one, I'm going to go with a Y and an X. Why not? This particular wee triangle here is actually a 3, 4, 5 triangle. It's just kind of hard to see that that's the case. But if you times each of those by 2.5, this gives you then kind of 3, 4, 5, and my beta then is going to be in here. It just makes life easier whenever you're resolving and kind of getting different angles kind of from here and there. It just means that my sine beta is O over H, which is 3/5, and my cos beta, should I need it, then is going to be 4/5. By taking moments about A, find the tension in the string in terms of M and G. So it tells us what to do here. We're taking moments about A and we want clockwise against anti-clockwise. So it's a uniform beam of length 2 meters. So that's going to be 1 times 8 mg. Then this distance here is 1.6 times t. And I'm not going across that B, I'm going sine, so it's going to be still across for cos, it's going to be sine B, sine beta, sorry. And sine beta I know then is 3/5. So 8 mg equals 1.6 times t times 3/5. So 1.6 times 3/5 is 24 over 25, and so I'm going to be dividing through then by that. So let's see, 8 mg is 24 over 25t. That means times by 25, so it's 25 times 8 mg all over 24 is t. That's a 3, that's a 1, so it's 25 mg over 3. And that then is in newtons. Find the magnitude of the reaction acting on the beam at the hinge in terms of M and G. So I'm now going to resolve up and down and left and right to get that information. So let's see what we have. Everything going up equals everything going down. So it's going to be Y plus T sine B equals 8 mg. Y plus T sine beta equals 8 mg. So that's Y plus 25 over 3 mg times by 3 over 5 equals 8 mg. That's quite nice, that tidies up. Of course 25 goes 5 times 1 time 1 time 1 time, so I get 5 mg equals 8 mg. So in this case I get Y is 3 mg everything going left equals everything going right. Let's take a look at what we have. We're going to have x equals then t cos beta. So cos beta is 4/5. Over 3 mg times by 4/5. That cancels there to give me 5. That cancels, give me 1. 5 times 4. Not quite as tidy, but 20 over 3 mg. In terms of finding the reaction then, so I have my x and my y. 20 over 3 mg, and then I have 3 mg going that way, and I have that. Now does it ask find the magnitude of reaction acting on the hinge? So that's my x one there, that's my y, so I need to do Pythagoras then for that. It doesn't ask what direction it's going at, which is handy enough. So it's 20 over 3 mg all squared plus 3 mg all squared, and again it's a case of putting that into your calculator. Don't worry about the mg's. The mg's are going to sit there at the end. It's 20 over 3 squared plus 3 squared, and finding the square root, and you get 7.31 mg, which is our final answer.